Hey, hi everyone. Today we are going to solve one of the interesting problem. So the problem is we are having a one integer and we have to figure out the square root of that integer. And if there is a no proper square root, we have to boil down that number to the nearest integer. Okay. So in this case, suppose this is 4 and 4 is a square of a 2. Like a square root of 4 is 2 in this case. For 16 square root is 4 and for 25 square root is 5. So in this case for numbers which are not square of any number like 8, so suppose we have to figure out the like a nearest number. So suppose this is a 2. 2 is square of a 2 is 4, but the square of a 2.82842, the square will be 8 in this case. So we have to round off that number to the nearest integer. So basically, we can see the brute force. How can we solve that by using simple common sense? We will try to optimize that brute force approach, and after that, we will understand how can we optimize it to the next level into the best approach. So let's get to the pen and paper. So let's take the examples. Suppose the number is 16. So can you think of a smallest number which can be the square root and the largest number? So we can say 1 is the smallest number which can be the square root and 16 is the largest number which can be the square root. So what we can do, we can just iterate from 1 to 16. Okay, that is a brute force search anyone can think of. So suppose 1 into 1 is 1, so it is still less than 16, right? So there will be a better answer which which can be the square root. So suppose this is 2. 2 into 2 is 4, still it is less than or 16, right? So we can go ahead 3. 3 into 3 is a 9, so 9 is also less than the 16, right? So take a 4. So 4 into 4 is less than or equal to 16. In this case we found the number, we found the actual square root. So let's take another example, n equal to 10. So once we get this number, do we need to iterate from 5, 6, 7, 8, 9, 10 until the 16? So our brute force is start from the 1 and iterate until the current number which is 16. So do we need to visit those numbers? So that is optimization on the top of a brute force. So we should iterate until the number where square root is less than or equal to the given number. So suppose the time complexity of a brute force approach is O of a n. By optimizing it, once we start iterating until the number which has the square root less than or equal to the given number. In this case, the time complexity will be O of square root of n, square root of n. So that is optimization, that is a better approach. We can still optimize this. So let's take another example, n equal to 10. The smallest will be 1, largest will be 10. So do we need to visit until the 1 to 10? Do we really need that? Like 8, 9, 7, something like this. So let's start with the 1. 1 into 1 is 1, then 2. 2 into 2 is 4, again 3. 3 into 3 is 9. Once we reach the 4, 4 into 4 is 16. In this case we have reached the limit. The square of a current number is greater than the given number. In this case, do we need to iterate for 5, 6, 7, 8, 9, right? So the square of these numbers, we can assume that it is always greater than equal to 10, so we don't have to visit this. So in this case we are reducing the time complexity from linear to the square root. So we will iterate until the current number square is less than or equal to the given number. So in this case we will return the 3. Okay, so that like a space complexity of a brute force is, so that is a brute force, that is a better. So space complexity of a brute force is, I think so, O of 1.
and space complexity for this also O of 1, because we are not using any extra space. So let's try to code this O of a square root of a n approach, the better approach. So we will try to code the brute force approach, and later on we will do the modifications to get to the better approach. So let's try.
So let's try to code the problem according to the solutions we have seen. So first of all, we will try the brute force approach. So brute force. So as we have seen, the time complexity of a brute force will be n, and space complexity will be O. So let's take a base cases. If x equal to 0 or x equal to 1, then return x. And if x equal to 2, in this case return 1. Now let's iterate from 1 to the current number x, which is x. So for current number in range of 1 to x, and if current number, the square of a current number, is greater than the given number, right? In this case, return the previous number. At last, return 0. We won't reach this condition anyways. So let's try to run this. It is working fine. So this is regarding the brute force, def brute force self comma x. Now let's try to code the uh, better approach, like average approach. So in this case, time complexity will be O of a square root of a x or n, which is a given number, and space complexity will be O of a. So in this case, we can copy the base condition, this one, and we can copy this one also. I don't think this is necessary, but still, the second condition won't be necessary in this case. And take the current number equal to 1, and take a while loop until current number square is less than or equal to x, which is given number. Then update the current number. अगर वो छोटा है then update, अगर वो छोटा है then update, and like 16 8 and जो भी है, we will iterate until the square root of that number only. We can't go beyond that. So return the current number and so on. So let's try to run this. Yeah, it is working fine. Let's try to submit this. So yeah, it is accepted. So you can see this. This is a brute force approach, which is taking the O of n time, which is a linear time, and this is a average approach, which is taking the square root of n time. Okay. So let's try to understand the best approach, which where we can solve this problem until the log of n time complexity. Okay.
So, as we have gone through the brute force and better approach for this problem, so let's try to understand the optimized approach. So, these are the two examples, 20 and 25. So, see, this is 20, and as we have seen, the minimum square root which can be is 1 and maximum can be 20. So, there is one thing, we have two ends, okay? And you can see there is a array between them, 2 3 4 until 18 19. So you can see this array is sorted, okay? These two conditions are satisfied, and still into this we have to search the element, okay? Search. So when these three conditions met, like there are two ends, start and end, and there is some order between the elements, and we have to search the element into that particular order. So in this case, we can use binary search, which is one of the famous algorithm. Okay, in this case, suppose this is 20, this is start, this is end. So we will figure out the mid. Mid is 10. So you can see 10 square is 100, right, which is greater than this 20. So we can assume that elements greater than or equal to 20, which is 11 to 20, definitely will be having a higher square root than 20, because 10 is also having a higher square root than 20. So in this case we will ignore this part, and our search space will be limited to this only, like a 1 to 10. In this case we will figure out the mid is 5. So 5 square is a 25. In this case also it is also greater than 20. So we can assume that this part 6, 7, 8, 9, 10. In this case these are also having a greater square root than 20. So in this case we will ignore this part, and our search space will be limited to this part only. Yes, equal to and equal to 5. Okay, in this case we will figure out the mid is a 2. So you can see, so mid is a 2. 2 square is less than 20, so we can assume that that can be the answer. So our start will come here, end will be here. So start will be 2, end will be 5. So in this case our like a mid will be 3. In this case, like, it is hard to draw here. 2, 5, 3. This is start, this is mid, this is end. In this case 3 square is 9. In this case start will come here, start and end, and you can see 5, 6, 7, 8. So mid will be 4. So 4 square is also less than 20. Then our start will come to the 4, and end will be, let me draw here. So 4 will be start and 5 will be end. In this case our mid will reach here, again it is less than 20. Then we can assume that then our start will come here. Start will come here, 5 comma 5, it is 25, and end will go down here. So in this case, 4 is a end and 5 is a start. So in this case our condition will break, because start is greater than end, and we have cached the answer. Whichever digit is having the square root less than or equal to 20, which is 4. The same for 25 also. So let's try to understand for 25. And we have two ends. Okay, and array is sorted between the ends. So, and we have to search the element into that sorted array. So in this case, again, figure out the mid will be the 12. 12 square is greater than 25, so we will skip this part, and then we will come to this part, 1 to 12. Mid will be 6. So in this case 6 square is greater than 25, then we will ignore this part. We will come to this part only. 1 6 is a 7. 7 square, mid is a 3. So in this case 3, and 3 square is a less than 25, so our start will come here. Now we will just search for this part. This part will be ignored. Then this is a 6 plus 3, which is a 9. Like a square root of, like the mid of 6 plus 3, 9 is 4, right? 4. In this case 4 square is less than 25, then our start will come here. We will ignore this part, ये बीच वाला part, ये वाला part we will ignore, and end will be on 6. And you can see 4 6 is 10, the mid is 5, and 5 square is equal to 25. In this case it is less than or equal to the 25, so return this element or cache this element. So that is a binary search. So at every iteration we are ignoring a half part of a array. So you can see I have to figure out the roll number. So suppose there are 100 students into the class, and I have to figure out the number, maybe 8. I have to figure out the student with roll number 8. In this case what I will do, I will figure out the mid from 1 to 100, which is 51. So 51 is greater than 8. In this case, I will ignore the rest part and I will follow the same procedure for further steps also. So in this case, we are ignoring half of the class at each step. So in this case, the time complexity will be O of log n base 2. And this is the best time complexity which we can have to solve this problem. And space complexity will be constant. So let's try to code this problem.
Try to code this. So first of all, take the base case if x is equal to 0 or x is equal to 1, return x. Then take two ends, smallest and largest. Smallest equal to 1, largest equal to x. And take a loop until smallest is less than or equal to largest. Smallest is less than or equal to largest. Until now, this is clear, right? So we have added a base case. We have taken the two ends. We have added a loop. Now take the mid. How to take the mid? Smallest plus largest divided by 2. If check if a mid into mid is less than or equal to x, which is target. अगर our current digit का square is less than or equal to our target number, then this can be our answer, right? So we will cache that. So let me add one more variable, answer equal to 1, and add a mid to the answer and move the start ahead. So start or not start, smallest equal to mid plus 1. Else, if our square root is greater than target, right, then we have to skip the right part. In this case, move the largest to the left direction, mid minus 1. So largest equal to mid minus 1. Is that clear? Return the answer. So the time complexity will be log n and space complexity will be O of 1, as we have discussed. So let's try to run this. Let's see if there is any bug. Yeah, it is working fine. Let's try to submit this. Yeah, it is working fine. ठीक है, चलो बाय.